welcome to the channel. Today, we are doing part 2 of one-dimensional kinematics in our physics course. So, last time, we learned about displacement and velocity, and along with that, we learned about scalars and vectors. So this time, it's going to be more in-depth. Let's get right into it. Okay, so let's start out by doing a quick recap. Last time, we learned about displacement and velocity. Those are the two main things. So to calculate displacement, we know it's the final position minus the initial position, which basically we learned. We said we use example point A, and we said if it comes back to point A in after going in a circle, then there's no displacement because you're no farther away than you started. So the final position, maybe I'm at 10 meters, and the initial position was at 0 meters, wherever you're putting it relative to. Then the displacement would be 10 minus 0 equals 10. So it would be 10 meters, the displacement. So the velocity, how we calculate that, we also learned. It's the displacement, so delta x divided by delta t, which means the displacement divided by the change in time. So the time it takes for the displacement to occur. And last time we used the example, it takes 2 seconds for the object or the person to move 10 meters. So the velocity would be 5 meters per second, and that would be the average, because we don't know if it moved 8 meters in the first second, only 2, so it's average. Okay, now we're gonna go in more in depth into acceleration and more kinematic formulas. Okay, let's start with acceleration. So as you can see, acceleration has the same line over it like velocity does, and it has similar units, except it's not meters over second, it's meters over second squared, because we're not just saying it's moving this much, we're saying it's accelerating, so the speed that it gains every time. Okay, so basically it's not displacement this time. For how to calculate acceleration is to do the change in velocity over the change in time. Let's say the velocity goes from 0, it's not moving at all, it's stationary, to 8 meters per second in 2 seconds. So it's 8 meters per second divided by 2. So that would be 4 meters per second squared. That's the average velocity. So we're going to get into how to, that's the average acceleration, not velocity. So we're going to get into how to calculate instantaneous velocity and acceleration later. But that's also pretty simple, so we don't need to worry about that for now. This is how do you calculate the average. So a good example for this would be a car. Usually a car starts stationary, right? So let's say there's a car race, and the car starts at the starting line. So that it's at 0 seconds, it's going 0 meters per second. And then they immediately start it. It takes time for the car to start up. It can't immediately go from 0 to like 10 miles per hour immediate after it starts. So it's, let's say on the first second, it goes 2. It starts going 2 meters per second. When it's on this second, it goes to 4 and stuff. So now we have to add those. So now we have a 6 meters per second over second 2. So that's 3 meters per second squared, the average acceleration. Okay, so that's basically acceleration. Let's get into more complicated, but not as complicated. So like more complicated, but if you get it, then it's really simple. So let's get into it. Alright guys, so thanks for watching. I really hope you enjoyed, and I appreciate if you're watching this. So I hope you learned something today, and next time we're coming back with the physics course. It's going to be about kinematic equations. So get ready for that, and I hope you like these. And if you like these videos, then make sure to hit the subscribe button, just like this guy's doing, and be sure to like the video because it lets us know that you like our videos. And comment any suggestions down below to help us improve. And thank you so much for 200 subscribers. It really means a lot. And we'll see you in the next one.